Okay, so our unit is numbers. I know that sounds kind of silly, numbers. I mean, really what we're doing here is we're starting right at the very beginning of what math is. And when we start with math, we start with 1 through 9 plus 0. Right? So we're going to talk about how to combine numbers. Before I get to that, just quick talk about what math is. What is math? This is off Wikipedia. Math is the abstract study of topics such as numbers. That's where we start, right? Eventually, we'll talk about structures, space, like say volume, area, surface area, that sort of thing, and change. We'll get to that. Here's what I want you to. Oh, I should have this real quick here. The reason why I give you guys notes, please don't. I don't want you guys writing down like crazy all the things that like on the board. I don't believe it's a good use of time for me to have you guys try to do this the whole time. Write down what I say. Right? Highlight in the margins. Does that make sense? I'm trying to change the way this operates so that you're not just frantically trying to write down what I got on the board before I erase it. Because sometimes, honestly, I'll just skip a slide entirely and I'll say, you guys can read this slide. Anyways, here's the highlight I want to talk about here. If we want to be good at math, though, we need that foundation again. So we need to work on our basics. So we're going to start off with arithmetic, so like you're adding, subtracting, multiplying, dividing, and eventually we get to our algebra. Here's a slide I found somewhere that just talks about all the different places in math that you could eventually study. And I mean, that's overwhelming, isn't it? So look at all the different things you could do. I mean, maybe you will, maybe you won't. That's not really the point, though. Right? The point here is just that I want to start giving you that basic foundation in case you do. Here's a slide that just shows how all the different streams are sometimes related. And math is really one of the bottom ones of the tree, right? You need math in order to build if you want to be in chemistry or geology. I like this slide. Why is this class important? Well, I mean, sure, I'll test you. Why do we take math? Is math useful? Yeah, I promise you it is. Are you going to do this in life? Nope. I'll tell you that right now, you probably won't. But that's not the point. If the whole goal of this was just to purely teach you the stuff you need to know in life, then school would consist of learning how to change a tire, change the oil in your car. But I mean, those are good skills to have, right? But that's not why we come to school. We come to school because we want to help you grow your brain so you can learn how to do any task, whether it's learning how to play pool or whether it's how to solve a math equation. So math is just a good tool to help us to grow our brains. Does that make sense? So I promise you, math is useful. Like, if you want to find places in life where math gets used, I can find you so many of them. Will any of you do it? Maybe you will. But I mean, if you ever, think, I'm never going to use Pythagoras' theorem in real life. Probably right, you won't. Right? Nowadays, you can just ask Siri to find the answer on your cell phone. But does that help you make you a smarter person? Does that help you problem solve? Does that give you the ability to grow? So I need you guys to know my philosophy behind teaching in math. Chemistry, physics, math, they're really cool. Like, they really, really are cool. The things you get to blow up, the smells you get to make, all the things that we do, it's fun. But it's just a means to an end to help you guys learn. Learning how to learn. Okay, so let's start at the very beginning. And the things I need you guys to know how to do are add, subtract, it's up here, right? Add, subtract, multiply, divide. So let's talk about some of the underlined words, because I haven't taught you guys before. Have you heard these words before? Things like integers? What's an integer? That'll work, yeah. Is there any restrictions? Like, are there some numbers that you can't count as an integer? No. Integers more or less refers to a whole number that's either positive or negative. So, like, for example, -3, that's an integer. 17, that's an integer. 5.327, though, not an integer. So, I mean, if you want to write this down, then, because this would be a good example here. Don't write down what's on the board there. Write down what I say. Integers are things like whole numbers, either positive or negative. So I need you guys to be able to work with those. Rationals, then. I actually have it behind there. Rationals are things like decimals or fractions. So we have to be able to work with those as well. And eventually, we're going to start talking about things called the irrationals, which maybe you've heard before, maybe not. Irrationals are things like square roots. By the time we are done this unit, I need you guys to be able to solve all of these questions. I give this to my grade 11 class, and many of them, they get a little overwhelmed at first, and they go, well, I got the first one. And after that, they go, can I have a calculator? And I tell them no. Why? Why can't I? Why don't I want to use a calculator? How's that help you learn? You know, I can type buttons into a calculator. You got a 4-year-old daughter, I bet you I can teach you how to type that in there. Is that helping your brain grow? If always you go to your calculator? So that's my goal today. We're going to rebuild this tower. Because right now, let's say that you can do a question. Let's say that second one there, 1.2 times 8.5. If I gave you a calculator, who could do it? Everybody could, right? But if I took away the calculator, this is you. Do you have a strong foundation though? So I mean, sure, once in a while, you can have a calculator, right? I mean, there's a time and place for it, right? Where once in a while you need to refill in the gaps, and we can use the calculator if it helps. But there are times where you need to develop that brain, and we need to know how to do this without the calculator. Here, this one's a challenge. How do you deal with two negative numbers? There's a rule for that. Anyone remember the rule for consecutive negatives? Yeah, it does. It makes it a positive, yeah. So like -2, you're adding 8, which means this one's 6. But I mean, then we got to get down to things like these guys here. This is the F word in math, fractions. It's the F word in math. Really, like who likes fractions? They're hard, right? But at the same point, why do we give you fractions? Because it helps your brain grow, right? It helps you learn. It stresses you. You gotta find that point there where it's not too hard, but it helps you learn something new. Eventually, we're gonna work on these ones here. Square roots and things with exponents. So let's start building that tower. Let's start right at the beginning. Let's talk about how to add. Is there a time and place for a calculator? Sure. But if you're constantly doing, like, say, 2 + 5 in your calculator, that's not good, right? You probably know that. It's a little embarrassing even. If you had to add 5,792 plus 92,412, sure, that would make sense, right? Well, but I mean, something like this, we should be able to do this without a calculator, right? So let's give it a try. 3 and 7, basic math fact, right? 10. 9 and 15. Okay, well, maybe you know right off the bat that it's 24. But let's say we need to re-go over real quick how to add, just because you forgot, right? Maybe you learn how to stack it like this, 9 and 15. Maybe put a line underneath it. You go, okay, well, 9 and 5 is 14. You like put the 1 right there. You guys done this before? Yeah. Right, and then, okay, well, there's a 1 right here. Add 1 more, 24. What about decimals? Well, okay, we can do the same sort of process. 18.2. How do I write the 8.27 with it, though? Well, you got to line everything up as one of the rules. So, like, this 8 is in the 1s column. This 8 is also in the 1 column, so we better line those guys up. And then this 2 goes here, and this one actually has 1 extra digit. This guy doesn't have a number in this column right here, and this one does. So we got to recall, okay, well, what are the rules to solve this? What do I add the 7 to? Yeah, nothing really, so 7. 2 and 2 gives 4. 8 and 8, 16, carry the 1, and 2647. What happens if I throw some negatives in? What if it's a negative and a positive? How does that work? Well, really, it's like subtracting in a way, right? Well, like if you have -3.2 and 8.9, putting those together like that probably doesn't work, because probably the most likely thing you'll do is you'll make that 11, you make that 12, and you say 12.1. And then maybe you'll say, oh, there's a negative sign, right? Maybe it's -12.1, but that doesn't really work as well with integers, does it? So we need to recognize that really what's happening here, we need to flip this a little bit. We need to say that we have 8.9, and we need to subtract 3.2. We actually need to subtract in this case here. So we need to maybe rewrite this a bit and say the 8.9 is the positive number. we need to subtract a 3.2. Makes it 5.7. Yeah. Yeah, go for it. What about this one right here? 30 plus negative 70. Can you add a negative? What happens when you add a negative? It's just subtracting, really, right? You're adding a negative, just subtracting. So this is really 30, subtract 70. Hang on, how do I do this? 0 minus 0, okay, 0. 3 minus 7, I can't do 3 minus 7. Well, you can in a way, right? Can we go into the negatives? Yeah, we can. 3 minus 7, we can make this negative 40. So it is possible to go into the negatives as well. Usually I don't do all the questions on every slide, by the way. I just do a smattering of them. Do you guys remember how to do this? Okay, so here's my point. If you do know how to do it, that's great. Level 1. Let's say there's something here where you're like, yeah, I lost it. Please don't feel bad. Talk to me later, right? Grab me during focus time. Grab one of the skills journals and work on specifically adding, right, if you need to. But if this is not a solid foundation, we gotta work on it until it becomes one, right? Skill 1, adding. Okay, next skill. We need to know how to subtract. I already talked about subtracting in a way, didn't we? Like 3 minus 7. I actually can do 3 minus 7. It just means you're going into the negatives, right? So I don't know how you've been shown how to do this, but maybe a number line would work, right? Where here's 3, and we're going back 1, 2, 3, 4, 5, 6, 7. So I'll make that 2, 1, 0, negative 1, negative 2, negative 3, negative 4. What happens if you have double negatives? It's positive, it's adding, yeah. So really, that's actually 100 now. Minus 30, minus 70, double negatives actually mean to add. What about if they're both negative? What if both of the numbers are negative? What if you have a negative 3.2 and a negative 8.9? How do you pull that off? Maybe one of the best ways of approaching it is you have a negative number, and you're going further into debt. It's like you owe somebody $3.2, and then you borrow another $8.9. You're still going to be in debt, right? You're just more in debt. Maybe one of the strategies here would be, let's not ignore the subtracts, let's just figure out what 3.2 and 8.9 is. But you were owing 3.2, and you were owing 8.9, so now you owe 12.1. Does that make sense? So sometimes when you have two negatives, actually we kind of were adding in a way. We need to add both of the negative numbers, and it just makes it further negative. What's the answer to this one? Negative 817 subtract negative 818. That's just 1, yeah. Because here's what happens. These double negatives, they actually need to add. So I have to think of it as you're 817 in the hole, and then you picked up $818. You picked up 1 more than you owed. So this one's actually 1. Let's try the next one. This one's even more challenging. Multiply. I mean, at some point, sure. There's a time and place for a calculator, right? Time and place. But I mean, for a couple of these right off the bat, I mean, if you're taking your calculator for 3 times 7, you're probably not in the right spot. You know what I mean? Oh, I don't want to kick anybody out of the group, but if you're still struggling with those sorts of things, we need to build that foundation, because you'll never get through if you can't do 3 times 7 is 21. Right? But I mean, maybe you get to a more challenging one, 9 times 15. By the way, you guys know that if you put them in brackets next to each other, that's like times. So, I mean, different way of timesing that. Maybe you do like this, 15 times 9. Maybe you've seen this method before. You go like 9 times 5 is 45. 9 times 1 is 9. Add 4 more, 135. Haven't seen that before? Okay, let's do that again. I mean, there's different ways of being shown how to do this. This is just one method. If you have 15 times 9, one method is to go this 9 times this 5, which is 45. So you write the 4 up here, like carry the 4, pull the 5 down here. So that's the 9 times the 5. Then you do 9 times the next number, 9 times 1, which is 9. But then add the carried 4. So 9 and 4 is 13. Does that make sense? Okay. If that's something that you don't know how to do, that's fine. It's not a big deal. Subtracting, multiply. Okay. That's where the journals come in. If you know that you're struggling on doing that, then we got to fill in the gaps because it's not going to do very well. Try to build a tower like this. I mean, heck, even the next one, it can scale that well. There's a hole, right? Let's try a challenging one. Let's move away to like something really hard, like this one down here. 1982 times by 9729. Okay, right off the bat, this is a really good example. Like, is that something you have to do in life? Or wouldn't you just grab a calculator for this? Yeah, you just grab a calculator. And yet, isn't it a good brain activity to see whether we can solve this by hand? This is a challenge. I mean, doesn't that help grow, even if it's hard? Let's give it a try. I'll do it as a group with you guys. Here's how you start it. You go 9 times 2 right here. That's 18. 9 times 8 right here is 72. Add the 1 more, that makes it 73. 9 times 9 right here makes it 81. Add 7 more, 88. 9 times 1 is 9. Add 8 more, 17. You know what? Right off the bat, in order to multiply, I did a lot of adding, didn't I? And if I was really struggling to add 9 and 8 and 7 and 1 and all those things, there's something missing there. Right? We're not done yet, are we? No. Not by a long shot. Okay, so next step. Do you guys remember what to do next? The way it works, and I mean, if we want to talk about why we do things, I can make another discussion later, but you put a 0 in the next column. Yeah. And the reason why doing a 0 is that these were all 1s. These are now 10s. And so we need to have a 0 to make this be part of a 10s column. Now we repeat the process and go 2 times 2 is 4. 2 times 8 is 16. Carry the 1. 2 times 9 is 18. Plus 1 is 19. Carry the 1. 2 times 1 is 2. Plus 1 is 3. Okay, well, we're still not there yet. I've now done the 9's column of 1s, the 2's column of 10s, that's where the 0 came in. Now I got to do the 7's columns of 700s. Anybody know what to start with? 2 zeros, good, yeah. Okay. 7 times 2, 14. 7 times 8, well, we better know multiplication tables. 7 times 8. 56. Plus 1 more, 57. 7 times 9, 63. Plus 5 more makes 68. 7 times 1 is 7. Plus 6 makes 13. Okay, again. Would you ever do it this way? No. That's not the point, though. The point is, you know what we've learned by doing this? We have really practiced our basic multiplication facts and our adding facts. And that's why we make you do this. Not because it's purposeful. Don't get me wrong. Somewhere in life, someone has to do math like this. You won't, probably. Right? The odds are you won't. That's not the point. We've helped you rebuild your single-digit addition skills, your single-digit multiplication skills, all by doing a problem like this. It's hard, but that's the point. Right? Hard problems help you grow. If you just pick the easy ones, you don't get any better. Last one. So we need 3 zeros now. 9 times 2 makes 18. 9 times 8. Okay, we got some work to do. 72. Plus 1 is 73. What am I up to? 9 times 9, 81. 7 makes 88. And 9 times 1 is 9, plus 8 makes 17. Holy smokes. I really hope I didn't screw up. Alright. Is there what the last thing to do is?
Add them.
Yeah, add it all up. Yeah. Boy, this one thing right here, by the way, we're only on level 3 of our pyramid. This is multiplying. Dividing. Exponents. Decimals. Fractions. It's a crappy tower, isn't it? It's falling over. Why is it falling over? How many of you really struggle with 9 times 8? Be honest if you don't mind. Struggle with 9 times 8. We now know what to fix. Does that make sense? That's one thing that I'm going to work on as a teacher with you. Let's find what your holes are and let's fix them. Alright, let's finish this question off. That's an 8, that's a 7, that's 18. Let's see, put those together, that's a 10. That'll make that 17, 24, 32. That'll be 3, 6, 9, 10, 18. That'll be 12. That'll be a 9 and a 1. Anybody take a calculator? See if I did it right. Try it out. It'd be really embarrassed if I get it wrong. Do that. But you know what? Actually, that'd be a good learning moment too. Because I'm human. You're human. You're allowed to make mistakes. The key is, can you find where your mistake is? Can you learn from it? Don't make the same mistakes over and over again. Are you right? So let's say that, yeah, question. Yeah, go for it. Let's say that question came up. Do I want you to do that by hand? Well, it depends on the scenario. If it's just about building skills, well, try it by hand, just to see whether you can work on that, right? But if that's part of a larger set of problems, no, use your calculator. Okay? Please, don't make me feel like you can never use your calculator again. But if all you ever do is your calculator, you can see why the tower is going to fall over, right? Because where we're trying to build goes so fast, so far, that you need to have some of those skills figured out by hand. All right, last one. You also need to know how to divide. And that's another one, right? Where if you can say that honestly, that's fine. It just means we now know what to work on, right? It's a skill that we need to practice. So, do all numbers divide evenly? No. In fact, I'm not sure any of these ones actually divide evenly. So we better re-go over real quick just the basics of how long division works. Which sucks, because long division is not fun. But it may come up. It's an important skill. So let's say you have 3 divided by 7. Real world scenario. I have 3 cookies and 7 friends. Can they each have a cookie?
No.
Let's say I tried to break them into pieces. How much of a cookie do you each get? Do you each get half a cookie, a third of a cookie? Well, that's kind of what the scenario is, right? So one of the ways you might have learned how to do this is say 7. How many times can 7 go into 3? Well, right off the bat, 7 doesn't go into 3, right? Do you guys know what to do next? I mean, when's the last time you did long division?
3.
Yeah, right? Probably. And then here's the thing. Have you used it since?
No.
Yeah. No.
Probably not. Because what have you used instead?
Remember I skipped that.
Calculator. Which means that your brain is atrophied. It hasn't worked on those skills. Sure, you don't have to use it every day, but it means that you've kind of lost that little bit that's helped making you a smarter person. So let's review. What you do here is you make it 3.0. All you do is you pretend that it's 7 going into 30. How many times can 7 go into 30? Well, now you're doing like some multiplication, right? So 7 times 1 is 7, 7 times 2, 14, 7 times 3, 21, 7 times 4, 28. Yeah, that works. Okay. It looks like you can go in 4 times. You'd say, okay, well, 4 times 7 is 28. We're just going to ignore the 0 for the decimal place right now. Anybody remember what you do at this point? Yeah, you subtract, actually. Pretend that decimal place isn't there for right this minute. What's 30 minus 28? 2, yeah. All right. Oh, by the way, since 7 didn't go into 3, it went in 0 times. We just put decimals all the way through this column, I guess. Alright, well then what we do is we like say put another 0 and we drop the 0 down and say how many times does 7 go into 20? 7 goes into it twice, right? 2 times 7 is 14, subtract it's a 6. And we can keep doing this until we die, because that'll never end. But it looks like it goes in about 0.42.
What?
0.42?
That doesn't make any sense.
I lost you on that, eh? Alright, let me try it again then. Because it probably has been years since you've done this, right?
I don't think I've ever done
So, 3 goes into, no, 7 goes into 3. Go backwards here. Alright, so can 7 go into 3? The answer is, does 7 go into 3? No, 7's bigger than 3, right? So it goes in, you usually put a 0 there. So a decimal place there. 3.0 then. Can 7 go into 30? We said 4 times, right? So put the 4 there. 7 times 4 then becomes 28. Let's just put decimals there. What's 30 minus 2.8? 28? But there's 2, right? Makes sense. And then we just keep repeating the process. We throw a 0 here. We drop it down. Can 7 go into 20? 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. No, it's too big, so it's 7 times 2. And then 2 times 7 is 14. Gives you a 6. And you can keep doing this process for forever, because this decimal will just keep going infinitely long. Grab a calculator. Check your work. But here's my point again. Once in a while, I'm not saying all the time, but we need to possess that skill. This is a little humbling sometimes when I do this activity with kids, where I go, you know, when you learned how to do this was probably grade 4, grade 5, and you don't know how to do it anymore, right? And so, pull another block out. That's all I've got for today's lesson. I know it sounds kind of silly, but I really believe this. We need to build a firm foundation. I need you guys to work on your basic math facts sometimes. And so, honestly, maybe that's where you start. If you feel like you've got add, subtract, multiply, divide, that's cool, that's fine. Move on. If you want to start working on the exponents pages out of there, that's fine too. Because, I mean, really, this is all grade 4 or 5, 6 now. Tomorrow, we're going to move on, and eventually we're going to talk about so many other operations. In this course, we're going to talk about exponents and square roots. Logarithms come in grade 12. Sine, you guys have probably already learned a little about sine, cosine, and tan, absolute value. So think of this tower again. This is my analogy. I really need you guys to start working on building a really solid tower. This block right here was missing. We got to put it in there. Because before we can do the next stuff, and the next stuff, and the next stuff, it better all be there. Otherwise, if you can't add or multiply, you're hooked, right? So here's my suggestion. If you want to keep the skills journal, that's fine, right? But my goal as a teacher, I don't want to be, please don't think of me as someone who's like, you must do 30 questions every day. Do what you know you need to work on, because really, who knows better than you, right? If you know I can't multiply, let's work on it. Let's you and me, let's sit down, come in focus time, I'll work with you. So, tomorrow we're going to do another lesson. For the last little bit of class time today, then I guess you've got 2 main things you can work on. One would be, do some more stuff in the skills journal. Find something you can't do and work on it. The other option is, and this is my recommendation, since I always give you an assignment that's due every week, do a little bit at a time. Never leave the assignment until, like, say, Friday afternoon. That never works. Procrastination doesn't work. So look at question 1 on the assignment and try doing that question. Really, it gives you some numbers and says, can you add, subtract, multiply, and divide them? So work on that for the next little while. When you guys do the assignment, by the way, can you put it on loose leaf? Minus the first question, it never will fill the page. There's going to be too much on there. Yeah, if you don't want to hang on to it, it's fine. Throw it back in the bin. Okay. But I need you guys to know a lot about my philosophy as a teacher here. You guys will learn as little or as much as you want to. If you want to learn, can you guys give me just one more second of attention? And then I'll shut up for the day. You guys can learn as little or as much as you want. I'm very laid back when it comes. If you just want to skate by and try to do the very, very bare minimum, I'll try to help you. You'll fail. It won't go very well, but that's your choice. But if you want to work hard, if you really want to learn math, I'm a pretty good teacher. I can help you. You just have to want to work at it. Okay? So we've got until, what time? 12:10? 2:10. So you've got like 20 minutes. You could pack up and just sit there and do nothing. That's probably not a good choice, though, right? Do something, right? Ask questions. Get help. Learn. We're here, right? So the last 20 minutes is yours. Let me know how I can help you learn.
I wanna